Hi, welcome to Market Board Videos. Today's video is about power. In our last video we talked about the definition from work, which was force times distance, and we said that impulse was force times time. And how do those things relate to one another? Well, they relate to one another through power. So let me give you an example. If you run upstairs or if you walk upstairs, you do the same amount of work, whether you run or whether you walk. However, you feel tired. You feel more tired when you run. It seems like it takes more energy, if you will, to run up the stairs than to walk up the stairs. Well, that's where power comes into play. How fast work is done is called power. So power is mathematically defined as work divided by the time interval. So how much work was done divided by how much time it took. And that's the definition of the word power, the scientific definition of the word power. So we have car A and car B. Car A has a certain amount of power. Car B has twice the power of car A. So what does that mean? Does it mean it does twice as much work? Does it mean it goes twice as fast? Well, here's what twice the power means. It means that car B can do twice the work of car A in the same time. Car B can do twice the amount of work as car A in the same time. Or it could mean that car B and car A do the same amount of work, but car B does it twice as fast, okay? Half the time. So the two options are same amount of work, less time, same amount of time, more work, okay? It can do either, but it can't do both, not if it has twice the power. The unit for power is watt, named after James Watt, and a watt is defined scientifically as 1 joule divided by 1 second. So it's important that our time, while we originally said time was time interval, we're talking about number of seconds. So if you're given your time in hours or minutes, you want to convert it to seconds in order to get watts. Again, a kilowatt is 1,000 watts, a megawatt is 1,000,000 watts, and let me give you an idea of what a watt is. The space shuttle launch, when the space shuttle used to launch all the time, it took 33,000 megawatts of power in order to launch. So that's a lot of power. It required a lot of power to launch. In the United States, we measure engines in horsepower and electricity in kilowatts. Now in metric countries, they don't do that. Everything's done in watts or kilowatts or megawatts. But in the US, we use horsepower. And I just want to, I'm sure you've heard horsepower before. I want to tell you what it is. 1 horsepower is about 0.75 kilowatts. So it's a little less than a kilowatt, okay? In America and countries that don't use the metric system, we tend to use horsepower. Again, it would be so much easier if we just went metric, because then we would have our engines and our electricity all measured in the same thing, and it'd be the same thing that everybody else in the world is using for measurement. All right? Let's move this one out of the way. This one doesn't like to move. Okay, so we're going to do 2 sample problems. The first one says, calculate the watts of power expended, or used, or required, when a force of 1 Newton moves a book 2 meters in 1 second. Well, we said that power was work divided by our time interval, and we know that work is force times distance. So power is force times distance divided by time. Our force is 1 Newton, our distance is 2 meters, our time is 1 second. Plug and chug, you get 2 joules. Let's make sure our units are okay. A Newton meter is a joule, and a second is a second. And a minute ago I said that was 2 joules. It's actually 2 watts. So we have a joule per second, which is defined as a watt. So our answer is 2 watts. Let's do one more example. Calculate the power expended when a 20 Newton force pushes a cart 3.5 meters in a half a second. So again, power is work divided by the time interval. Let's make sure our units are okay. Force is in newtons, distance is in meters, time is in seconds, so we don't need to convert anything. And now let's put it in. 20 newtons times 3.5 meters divided by 0.5 seconds. 20 times 3.5 is 70, and it's Newton meters, which is called a what? A joule, you're right. 70 Newton meters divided by half a second, or 70 joules divided by half a second. 70 joules divided by half a second is 140 Newton meters per second, or joules per second, or watts. So our answer is 140 watts. So the power expended is 140 watts.